So finding the sum of a finite geometric series, we'll talk about infinite geometric series later, but the sum of a finite geometric series is with that formula right below there. The sum of the first n terms of a geometric series with a common ratio, other than 1 because that wouldn't change anything, is your first term, a sub 1, times 1 minus your ratio to the nth power over 1 minus your ratio. So just a reminder what everything is. S sub n, that's your sum. A sub 1 is your first term. R is your ratio. And n is the term that you're going to, or the terms you're finding the sum for. So if we have all those pieces of given information, then we can find the sum for the series. So it's, number 8 says, consider the geometric series 1 plus 5 plus 25 plus 125 plus 625. So it says, find the sum of the first 10 terms. So we know the first term. We're trying to find the sum. We know that we're going to find the sum for the first 10 terms. All we need to know is what the ratio is. So what is the ratio from 1 to 5? 5 to 25. 125 to 625. What are we multiplying by each time to get us to the next term? And it's 5. So that is your ratio. So if we're trying to find the sum, so I'll write this as the sum of the first 10 terms equals your first term, which in this case is 1, times 1 minus your ratio to the nth power. So how many terms are we finding? 10. So 5 to the 10th power over 1 minus your ratio, which is 5. And again, this is just right off the formula, which you guys do not have to memorize. And we can just plug it right into the calculator, and you get 2,441,406. So that's why you don't want to have to, by hand, add all of that up. Because as we multiply those by 5 every single time, they're going to get very big. But you can, of course, multiply each one and get all 10 terms. But that is your formula for finding the sum of a finite geometric series, as long as you have all the given information that you need. I'm just going to get you guys started with number 9. It says, find the sum of the geometric series. So instead of giving us the series and us finding the rule, it's actually given us the rule just in summation notation. It wants us to find the sum of the first 6 terms. So 4 is your a sub 1, 3/2 is your ratio, and you're going to the 6th term. The series says that you're finding the sum of 6 terms. So you have everything you need. So the sum of the first 6 terms equals the first term, which is 4, times 1 minus 3/2. You could also make it 1.5 if you wanted to the 6th power over 1 minus 3.5. So just make sure you guys are typing this in correctly. So I said I would start, we'll just do it together. So just make sure I would try and type it in and see that you do get the same thing. It should be about 83.13 is the sum for this series. So if you notice, we don't even care about this I minus 1 here at the top. We didn't even use it. So we're just looking for the pieces of information that we need. So number 10, it's an application problem, and it says in 1990, the total box office revenue at U.S. movie theaters was about $5.02 billion. Billion is 9 zeros. But anyway, from 1990 through 2003, so including 2003, the total box office revenue increased about 5.9% a year. So it says, write a rule for the total box office revenue, A sub n in billions of dollars, in terms of the year. So it says that n is going to be our years, and we're going to make 1990 the first term, or the first year. So 1990 through 2003, so 1990 to 2003, we have 1990, 91, 92, 93, 94, 95, 96, 97, 98, 99, 2000, 2001, 2002, 2003. Yes, does it seem stupid to count on your fingers? Yes, but it's 14 years. It's from 1990 to 2003, so you have to include both of those years, 1990 and 2003. So, 14 years. So it says the first year, they were at $5.02 billion. So that's your first term. So we're going to write A sub n equals the first initial value that it was, $5.02 billion. And since our term value is in billions of dollars, that's fine. We don't need to add all those zeros. And then we need to find the ratio. So we need to be careful. We've talked about this in the growth and decay unit. We're increasing in revenue, correct? So it's adding 5.9%. So it's a growth factor or a growth ratio. So it's not going to be 0.059 as the ratio, because that would make it decrease. This is where we have to add or subtract it from 1. So the ratio is actually 1.059 because we need to add the amount that it's growing each year. So going back to those growth and decay factors. If it were less than 1, it wouldn't actually be growing if you guys would have just used 0.059. And then if you flip your page, just to remember what the rule for the geometric sequence looks like, it's to the n minus 1 power. It's a sub 1 times your ratio to the n minus 1 power. So that would be your rule for this given scenario. So if something were decreasing in value per year, you would take 1 and subtract that value. So just remember to keep that in mind. So what was the total box office revenue at U.S. movie theaters for the entire period? So from 1990 to 2003, total of 14 years. So when we're finding the sum, we need the ratio, which we have. We need the first term, which we have. So we've just got to plug it in. So we're going to find the sum. So you can write like sum of n. You can write the series. It doesn't really matter which way you guys do it. If you do it, write it like that or like this. They both mean sum. So we'll just do S sub n since that's what we've been doing. So the sum for the first 14 terms is going to equal your first term, which is that 5.02, times 1 minus the ratio, so 1.059, to the number of terms we're finding, so 14, over 1 minus 1.059. And again, you just go ahead and plug it right into the calculator. So 104.76. So about $105 billion. And again, that's not what it's at on the 14th year or in 2003. That's the sum of all of those years added up.